Hi, this is Vasavi again from At Home Tuition. Today we are going to see the relationship between the product of two given numbers and the product of the LCM and GCF. So what they say is, for any two positive integers, so the positive integers here I have taken it as A and B. When we find the product of HCF is nothing but the GCF. HCF is highest common factor and GCF is greatest common factor. Both means the same. So the product of HCF and the LCM of these two numbers will be equal to the product of the numbers itself. Okay. So let us see with an example. So here they've asked you, find the LCM and GCF of the following pairs of integers and verify that LCM times GCF is equal to product of two numbers. Okay. So we need to find the LCM and GCF first. So let me divide them in step ladder method. So I take the numbers 510 and 92 and start dividing it with common factor. Since both are even numbers, you can start with 2. So that is going to be 255 times, right? Yeah, and 92 goes into 46 times. Okay, and you don't find any common factors for these two numbers, so we can say that the GCF of two numbers is 2. Okay, that's all. Now let's keep dividing this until we get prime numbers. So you can divide one by one, no issues. So first let me start dividing by 5. So this is going to be 51 and 46 doesn't go, so you can write it as it is. Again let me divide this by 3. So what happens? 51 will go in 3 17 times, right? 17 times, and this 46 is written as it is, it is not divisible by 3. Now let me go in for now 17 is a prime number, so you can stop that. Let's continue with 46. So what happens? 46 goes into 23 times and there it ends, right? You have got both prime numbers here. So your LCM would be the product of all these, right? This L shape. Remember, we have done LCM and GCF before, so you can go through that video if you want. So you have to multiply all this. So that is equal to, you have two 2's, right? So let me write it as 2 squared times 3 times 5 times 17 times 23, right? So that is going to be equal to 23,460. Okay. So now you have found out the GCF and the LCM as per the question. So half the question is done. Then you need to verify that the product of the GCM and LCM and GCF is equal to the product of, so this one you need to prove, right? So for proving that, let me find out I take it as LHS, okay? The left hand side of the equation given is LCM times GCF, right? So that is going to be, your LCM you got here is 23,460 times the GCF, which is 2. So you get it as 46,920, right? Now let's find the RHS. I'm doing my RHS right hand side here. So as per the RHS, I have to find the product of two numbers. So I take it as, that is equal to, that implies 510 times 92, right? Yeah, that is also equal to 4690. So you can say that your LHS is equal to your RHS. Therefore, LHS is equal to your RHS. So the given statement is true. Okay, you have verified it. Understood? So simple. Let's do one more on this. So again you have 336. Let me take the step ladder method. So that is 336. You can use any method, but I find this easier. Divide by 4. So this goes, both are even numbers, so I divide by 2 first. So that is going to be 168, right? And here it is 27. Now 168 and 27 will not go in 2, but it goes in 3. The 3 is a common factor. So that is 56 and here it is 9. You don't have any more common factors. So I write my GCF as 2 times 3 because these are the only 2 common factors you've got. So that is 6. Your GCF is 6. Now let's proceed for the LCM. So we can divide one by one, okay? So I am dividing this by, okay, let me complete the 9 first. So this is 3. So 56 doesn't go in 3. So I just write as it is. This is 3 here. Again, divide by 3. So this is 56 is written as it is and this is 1. Now let me divide the 56 by 2 because it's an even number. So that will be 28 and 1. Now again I can divide by 2. So that gives me 14, right? 14 and 1. Again divide by 2. You get 7 and 1. We can stop here because 7 is a prime number. So I can stop there. So now your LCM would be the product of all these numbers. So let me write the LCM. You have 1, 2, 3, 4 2's, right? So that is 2 raised to 4 times. How many 3's do you have? 1, 2, 3, right? 3 3's. So that is 3 cubed. And then you have a 7. Yeah. Times 7. Okay. So this is going to be, the LCM is equal to 3024. Okay, now I got the LCM and GCF. Now take the left hand side first, right? So I take the LHS first. LHS. So that means the LCM times GCF, right? So that is, LCM is 3024 times the GCF 6. So that will give me 18,144. Okay. So this is our LHS. Let us check the RHS, the right hand side now. So in the right hand side you need to find the product, right, of 2 numbers. So let me multiply 336 times 54. So that will give you 18,144. So your LHS is equal to RHS and the statement is proved. So the statement LCM times GCF of 2 numbers is equal to the product of 2 numbers is true. The next problem, okay, see here they've given the HCF as 9 and you are asked to find the LCM. We know LCM times HCF or GCF, whatever you call it, okay, is equal to product of 2 numbers, right? So your LCM is what you don't know. Let us keep this LCM here and divide throughout by the HCF. So you get LCM is equal to product of 2 numbers over HCF, okay? Instead of doing that step ladder method, I just use this statement and find the LCM. HCF, okay, this is F, okay, or GCF, whatever. Therefore, your LCM is equal to product of 2 numbers is 306. The numbers are 306 and 657 divided by the HCF, which is 9. So that will give you 22,338. So now you got the LCM without doing any calculation. The step ladder method or prime factorization method. I just used the formula and I got what is my LCM. So that's 22,338. Understood? Same way, if LCM is given and if HCF or GCF is asked, you can just find the GCF with this formula, the product of two numbers divided by LCM. Okay? So that's it. And I would also like to tell you one thing. Every composite numbers could be written as the product of powers of prime numbers. I tell you, numbers, you have two types of numbers, right? So I just segregate numbers as prime and composite. Okay? Prime and composite. I hope all of you know what is a prime number. A number which is divisible by itself and by one alone is called as prime number. And the other numbers are composite numbers. So we can represent any composite number. Say for instance 55. This could be written as 5 times, by factorization you can say it is 5 times 11. And 5 and 11 are the factors of 55, right? So these two are prime numbers. See? Likewise, if you take 100, take for instance 100, this is going to be 2 square times, 2 square is 4, 4 times 25, right? So that I can write it as 5 square. See, you have 2 and 5 as prime numbers. Any number you take, say for instance 99. This is again 99, I can split it as 3 squared times 11, right? So any numbers you take, it is going to be the product of powers of prime numbers. So using this principle, I am going to solve this sum. Here they say, explain why these two numbers given here are composite. Okay. So the two numbers, I take it as n1 and n2. And I am going to solve it separately to show that it is a composite number. So how do I show that it's a composite number? By proving that it is the product of prime numbers. So now the n1 is 7 times 11 times, look at the signs in between, all this is times and here it is plus 13, okay? So you have this as one term and this is another term. So I take the common term out, the 13 I take out, common factor I am taking out. So this will be 7 times 11 times 1, right? Okay. Plus 1 because 13 is taken out. So this is going to be 13 times 77 plus 1, which is 78. So that is equal to 13 times 78. And I'm just going to factorize this. 13 is already a prime number. Let me split this 78. 78 could be written as, if I take this as 2, then this is going to be 39, right? And 39 still I can factorize. It is 3 times 13. Okay, so I got all these as prime numbers here. So I can write this as 13 times 13 times 2 times 3, right? So this is 13 square times 2 times 3. All the numbers are prime, right? So we can say it is a composite number. Now let's do n2 because we have been given two numbers. So n2 is like 7 times 6 times 5 times 4 times 3 times 2 times 1 plus 5, right? So here 5 is, this is one term, all this is one term and this is another term. So I find 5 common factor. Taking the 5 out, I will have 7 times, 6 times, 4 times, 5 is gone out, 3 times, 2 times 1 plus this 5 is gone out, so it is 1. So that's nothing but 5 times the product of all this 1008, okay? Plus you have a 1 here, so that is going to be 5 times 1009. 1009 itself is a prime number and 5 is also a prime number. So here the results are all product of prime numbers, right? So you can say hence they are composite numbers. I hope this video was useful to you. Thank you. Have a good day.